We've had a pretty busy day today. The FAA here in the United States last night began issuing NOTAMs for related to the 5G issue at just after midnight. As I understand it, there are around almost 1,500 of the NOTAMs that have now been issued affecting flight across the US should the 5G wireless network from Verizon and AT&T go active. We are bringing you a group of panelists today that are subject matter experts. They've been working on this issue as part of the industry coalition for many months. And so we think that we'll be able to provide a lot of information. We know that it's vital to many of you who have flight operations. Let's get into our panelists today. Our moderator today is John Shea. He's our Director of Government Affairs here at HAI. He's also our subject matter expert. We have Nick Kefalas, who is a Lockheed Martin Technology Fellow at Sikorsky Aircraft Corp. And we have Seth Frick, who is a radar systems engineer with Honeywell. For those of you who are new to our webinars, we do try to make these as interactive as possible. We do encourage your questions. We ask that you use the question module at the bottom of your screen so that you can submit questions. Please don't use the chat feature. You're welcome to talk amongst yourselves, but we try to keep a focus on the questions for the very end of the webinar. So after John, Nick, and Seth have finished their presentation, their discussion, we will try to get into as many questions as we can. These webinars are being recorded. We do encourage you to share the recordings. You're welcome to go back and look. We'll try to get the link to the webinar out tomorrow as early as possible. Sometimes, depending on the technology, it could be as late as Monday before we get those posted. Actually, probably Tuesday since we have a holiday weekend coming up. So now I'd like to stop sharing. I would like to invite John Shea to bring his camera up.
Hey, Dan.
Hey, John, thanks for joining us this afternoon. To say that this is a vital topic is kind of an understatement. And it seems like the airlines have gotten most of the attention, but we know that Rotorcraft are certainly going to be affected by the integration of this 5G network. Is that correct?
That is correct, Dan. And that's exactly why we wanted to hold this webinar tonight, was to give the much needed attention to rotorcraft operators that are facing a great deal of uncertainty with the recent ADs and NOTAMs that have taken place. And as we just heard from you, that those NOTAMs were issued late last night into early this morning, and then kind of trickled in throughout the afternoon. So a whole lot to process there. But before we really dive into the subject matter tonight, I just kind of wanted to give an outline of the kind of sequence of events. As Dan mentioned, we want to get into questions and answers because as we've heard from many of you over months now for questions on exactly what the impacts are going to be, we want to take this opportunity to hear from you. And we've got two great panelists with us tonight that have been deeply involved with the technical discussions that have been taking place, dating way back into early 2020, but even further back in the process. And then the cadence of these meetings went from weekly at about an hour to an hour and a half to a couple times a week to around the clock. So I think they're going to provide a lot of information and clarity, and we really want to encourage folks to don't be bashful. Put your questions in the queue, and we'll be sure to address them. With that said, we're going to look through not only just how we got here, but the ADs that have come out, the NOTAMs, and kind of like a current state of where things are now, and a little bit about the AMOC process. And then we'll kick things back over to the group to discuss whatever questions may come up. I did want to kind of provide an overview of how we got here today. If you're reading the headlines, it depends on, I guess, where you're getting your news a lot of times, but a lot of people would have you believe that this issue just kind of came up overnight. That's most certainly not the many other organizations have been voicing concerns with the repurposing of spectrum in the C-band. And when this occurred, we knew that there would be a certain level of interference that could interfere with the radio altimeter, which we all know is a critical piece of equipment that's on most all aircraft, especially commercially. And we have been working diligently since 2017 to voice these concerns. And it's well documented in the FCC docket and with FAA and DOT and NTIA, Commerce, and even more recently with the White House. You know, when this first started, there was question about whether or not the interference issue was going to be something that was even an issue. As many have heard, you know, over 40 countries have been able to operate safely with 5G. That's kind of a misleading statement. It's an apples and oranges comparison to what we have here in this country, and the power levels and the complexity of our airspace. So, you know, as advocates on your behalf, it's our obligation to make sure that the policymakers and legislators are well aware of the stakes of what they're doing. And we have been working that process for a long time. And before I go back into too much of a history lesson, I'm very pleased to provide some I think will be well-received news from many of our helicopter air ambulance operators, which were certainly facing a great deal of uncertainty. Today, we received notice that our petition for exemption was partially approved. The petition itself was to all of Part 135 and also to Part 91 with night vision goggles. Now, while all operations were not exempt from the restrictions, helicopter air ambulance, given that it provides you know, a high level of public interest, and the mitigations that we described in the petition were granted because they maintain an equivalent level of safety. And I'd like to, if I could, just very briefly kind of touch the high level on this. I think, you know, the focus of our discussion tonight will be more towards the AMOC process, and we'll be sure, I promise you, to set up another webinar in the very near future where we'll be discussing how this procedural or operational exemption from the rule was accomplished. And but with that, it will provide helicopter air ambulance the opportunity to operate in NOTAMed airspace, the ability to use night vision goggles and unimproved landing sites where NOTAMs are identified to cause problems with an unreliable radio altimeter. Now, there are conditions that were included with this. And again, those are part of the mitigations that we discussed. But that's the aircraft is equipped with an operable radio altimeter. And there is a large discussion to be had on inoperable versus unreliable, and functioning in a normal manner versus unreliable. So look forward to that at a later date, but that was a key part of this. And keeping in mind too that the safety regulators at FAA, they were looking at two different issues, one being addressing safety and the other being addressing regulatory compliance. But in order to have you know, to be able to use night vision goggles, it needed to be a movable searchlight involved. Also needed to establish a crew member radio contact on the ground, and there'll be some training involved that's necessary in order to utilize this exemption. But very positive development, and we have a lot of people to thank for filing comments, and really we rely so heavily on our members' subject matter expertise on this, and I think we developed a good product here, but our job's far from done. There's a number of issues and operations and industry segments that were not covered in this exemption, and I think we learned a lot from this recent development on how to get us there, in addition to pursuing some of the issues with AMOCs and the opportunities we'll have there. But I do want to get into that at a later date, and I'm going to shift back to kind of where we were. And, I want to say through extensive advocacy work on the Hill and with regulators, we were able to, make some incremental progress on the Rotorcraft side. However, as many of you know, commercial transport has taken priority, and obviously with the need to maintain travel and the supply chain crisis and a number of other issues, this was somewhat expected. But the mitigations that were offered in many ways to help the helicopter industry were insufficient. So we still have a lot of work to do, but some of those discussions, technically, I think Seth and Nick both can kind of speak to this. There's been some reason for optimism here lately, and again, we've got a couple avenues now to get any of our members that are facing restrictions back out there and flying. But with that, I will kind of move into now just the meat of the discussion, if you will. And dating back to December 28th, this was a month after the scheduled deployment of 5G. On December 5th, we received airworthiness directives for both air transport and helicopters. That was significant in and of itself, that would be treating the two of us differently, but I think there's a lot of comparisons to be made there and some applicability. And I know there's been a lot of question about who on the Rotorcraft side this would apply to. And, there were 4 different bullets that of note for us to consider. And, I think one of the largest was, the takeoff and landings and other procedures in noted airspace. But there is kind of a path there. And I'm going to open it up here. If Nick or Seth want to kind of dive into some of the interpretations and work we've been doing, just focus on the AD. If you have any kind of comments to add to that, please feel free to join in now.
Yeah, thanks, John, and thanks for having us on here. So I can speak to that a little bit. We're learning more every day about what the overall process is going to look like, and as you noted, a lot of this has been focused in the immediate near term on transport category airplanes. But I can share my screen here, and we can talk a bit about we have these ADs in place, and they specifically call out the alternative methods of compliance, the AMOCs, as a potential way to obtain some relief from the operating restrictions that are imposed by those ADs and any subsequent NOTAMs that have now been issued. So the way this process is going to work to obtain an AMOC and get some amount of relief from the airworthiness directive restrictions for the fixed wing case for airplanes is essentially the altimeter manufacturers are going to be providing test data to the aircraft manufacturers, indicating the susceptibility of their particular altimeter model that is used on those aircraft. And that will be used to define something that we've called a protection radius. So the FAA has been provided information from AT&T and Verizon on all of the 5G base station locations around airports. And they will take that protection radius for a given aircraft and draw a circle around all of those 5G base station locations. And then they'll look at airports and draw additional circles with a 2 nautical mile radius centered at each runway threshold for all the runway ends at that airport. And that gives you this big bubble or big area around that airport. And basically, when you apply for an AMOC and provide that protection radius information, the criteria is if there's no intersection between the base station bubbles and that airport bubble for any of the base stations around an airport, then that aircraft is going to be cleared to operate into that airport without those airworthiness directive restrictions applying. So the case that's shown here has a pretty small protection radius around the base station, so that would indicate a much more resilient altimeter model. This is a case with a little bit larger protection radius, but still able to clear this particular airport. And this is a case where the protection radius is so large that it does actually intersect with this bubble around the airport. And this would indicate that for this particular airport and this particular aircraft, the AD restrictions would still apply. So basically, when the FAA is going to be processing and approving these AMOC applications from aircraft manufacturers, they will provide in response a list of airports which have NOTAMs at which that aircraft is going to be able to operate without the AD restrictions, and ones at which the AD restrictions would still apply. So one of the fallbacks with this initial approach is if you have a scenario like this where there's a 5G base station that's actually located inside that 2 nautical mile area around the airport, that means that no AMOC is going to be able to clear this airport, even if no matter how small the protection radius is. So this is an area of concern that's been raised, and we're in the process of developing additional follow-on strategies to leverage some of the restrictions that have been put forth by AT&T and Verizon, and do some more sophisticated modeling of the scenario geometries and things like that to help address these cases and basically clear more airports from more aircraft. So there's a final slide here, and I can't take credit for these slides myself. These were compiled by one of my colleagues at Boeing. So I want to thank him for that. But basically, we know at certain priority airports, there's going to be areas in which base stations can't be installed. And so if the protection radius is sufficiently small for a given aircraft type, that should allow clearing of that airport. So this is the process that's been outlined as we understand it for the fixed wing aircraft. And like I said, it was developed specifically with the transport category airplanes in mind. We are having some initial discussions between industry and FAA on how to apply this process or modify it to gain relief from some of the airworthiness directive restrictions for the Rotorcraft case. And I think as a first step, there will be something very similar to this done with an established operational area around known heliport locations, for instance, and then evaluating the protection radius for any base stations around that heliport. So it's still details are changing every day on this. We have daily meetings between industry and the FAA to discuss this. Things are constantly evolving, but we do expect a similar process to be made available in the very near future here for the Rotorcraft cases. I'm not sure, Nick or John, if there's anything you'd like to add to that or any questions.
Yes, good evening, everyone. Thank you, Seth. The only thing that I want to add is that for the helicopter community, as most of you understand, we're dealing with a different, outside of a helicopter that has designated helicopter landing procedures, which we would follow the specific AMOC graphics that Seth put on the screen here. For a helipad specific scenario, we would have to assess those landing conditions under different criteria currently. One of the things that we are looking at doing for helicopters is because the cellular industry will be using different levels of power flux density emissions for the heliports. And for example, let me clarify that. Currently, the cellular industry is proposing a minus 30 dBm per meter square per megahertz power flux density around airports. But for heliports that are standalone facility or helipads, that value is currently set at minus 13 dBm. So we're approximately twice as high in power emissions and radiated emissions from what on airport helipads would be facing. So as such, the circles that Seth was indicating previously will be modified significantly with respect not only to the approach plate conditions for that particular heliport or helipad, but also with regards to the radiated power emissions. However, the process in and of itself of creating an AMOC to allow usage within the restricted zone here is pretty much going to be the same. Specifically, as it stands today, the RA manufacturers are currently conducting testing on a variety of model radio altimeters in order to quantify their robustness and susceptibility to the proposed RF levels by the cellular industry. Once the manufacturers complete these tests and quantify their results in the reports, they will be sharing those results with the FAA and with the industry manufacturers in order to achieve an FAA letter of acceptance at the manufacturer level. That FAA letter of acceptance would then be considered a conformed set of data that would then be provided to the OEM and STC holders or field approval holders to support their AMOC application process. So as an aircraft manufacturer, currently the FAA is proposing a process where using the RA manufacturer data, the aircraft OEM would submit a AMOC application that would cover a global set of aircraft, not a singular one as initially was proposed, but they would be allowed to go after a global set of airports or currently NOTAMs and submit a global application package using the RA models and reports. And then they could include a 5G protection radius estimation. And with that statement, the FAA would then assess using their own database, which would contain the actual geolocations of the 5G towers, whether or not the 5G interference would work in conjunction to the slides that Seth showed with those avoidance zones around the 5G emitter towers. Should the FAA find that a particular radar altimeter and aircraft model combination is cleared to meet the 2 nautical mile radiuses around the heliports, helipads, or airports, they would issue an AMOC, global AMOC approval letter identifying the specific airports and runways that would have no 5G interference for the particular model aircraft, thus allowing the operators to continue to use the aircraft with those airports. However, in the cases where certain model radar altimeters do not meet those criteria, they would be excluded from that global AMOC approval letter. So in this process, the OEMs would then be able to take the specific AMOC approval letter with the qualifying airports, helipads, et cetera, and provide that information to the operators for them to be able to understand where and where not they can operate.
Right, and this is, like I said, this is the first step that's been identified as a way to try to clear some of these restrictions for big swaths of aircraft fleets as quickly as possible. But it's going to be a continuously evolving thing, and in particular, the altimeter performance across different models varies very drastically. So these protection radius values can be anywhere from a few hundred feet or less to tens of miles, depending on the actual altimeter that you're talking about and how it performs against potential 5G interference signals. So there's going to be a very wide range of different potential impacts and different levels of relief that can be obtained through this process. At some point, there is likely going to be a need for many altimeters to be retrofitted or replaced to improve the performance and improve the compatibility with 5G interference to be able to get complete relief from these restrictions. So that's something that within the industry, and particularly as an altimeter manufacturer at Honeywell, we are have very much in mind and are going to be dedicating significant effort towards in the near term here.
So,
Yeah, go ahead, John.
No, I was just going to say you hit on a couple of points there. Just wanted to touch on. What we do know is that as time goes on, they're going to be turning on more towers, which kind of complicates the process or stands to with additional kind of need to go back and renew through this AMOC process. I was wondering if you might be able to elaborate on that a little bit and what that environment could look like.
Yes, so currently, both Seth and I have been working with the FAA Technical Committee almost on a daily basis here, as well as the cellular committees. One of the things that the FAA has initially stated was that every 3 months, they would receive an update through the FCC that reflected new cellular towers that would be activated within certain of the economic area zones that they are operating in, thus increasing the density of the 5G towers, keeping in mind that 4G, unlike 5G, did not require as many towers for coverage. So as we roll out 5G, in order to get the same level of network performance, the cellular operators are forced to actually increase their tower densities in order to provide the same coverage that they had under 4G. So as they begin this rollout, the original idea was for every 3 months, the FCC would actually submit to the FAA an updated set of tower locations and activations, which would then go into this FAA Aspire tool, which would be used to reevaluate or reassess exactly what Seth was showing here in the graph, basically additional towers popping up around these airports and potentially encroaching into this perimeter of 2 nautical miles from the TDZ zones on the runways. And as such, we would basically have to repeat the AMOC process again on a 3-month period, not 3 months from the granting of the actual AMOC exclusion zones for operation, but 3 months from the update, from the last update that the FAA put from the FCC with respect to new geolocation towers. Now, before anyone starts panicking about that, that is still something that's being discussed with the FAA and the FCC. We're not sure where we will end up on this yet. So that's still something that's under discussion and debate.
Curious too, Seth, you touched on this a little bit. I know you guys are allocating a lot of resources towards, getting new radio altimeters to market. And, curious if you thought there was a timeline for when that might be available. And then also too, just kind of, we're coming up quick on January 19th. What's, the typical AMOC process is a little bit longer, but, it seems like they're getting closer to, a path to acceptance for, again, larger swaths of fleece. So I think, if you could, that would be a helpful thing to know to kind of level set expectations.
Sure. There's multiple different timelines and time scales at play here. So the most immediate, of course, is January 19th. What happens on that date, and that's what this whole initial first step AMOC process has been specifically crafted around, is what can we actually get in place in so little time. So both industry and the FAA are really blazing completely new trails on this whole process. A typical AMOC, is going to be months or longer to completely establish. And even for an AD, the compliance period for an AD is typically much longer too than what was afforded in the ADs that were actually put out. Updating flight manuals by January 4th was I think what was required there. Whereas typically the compliance period for something like that could itself be months or longer. So we recognize that this approach isn't perfect, and there's going to be opportunity to iteratively improve it. And in parallel, we're going to be looking at the longer time period of what can we do to improve existing altimeter performance on currently equipped aircraft, whether that's through retrofit, adding external filters, or swapping for different altimeter models that may offer better performance. So that's something that we're already working on, in earnest, and trying to fast track as much as possible, understanding that, installing a filter, it's not as easy as just going and picking something up off the shelf and slapping it on your certified aircraft. The filters themselves are custom parts built to spec. They're going to have to be qualified. We're going to have to have adequate demonstration that installing that filter does not degrade the performance of the altimeter system to a point where it's no longer compliant with its requirements. And then finally, to actually install that, you're going to have to have some kind of updated approval at the aircraft level, whether that's an STC or updated field approval. So we've been working on all of those things in parallel. We've had discussions with the FAA about them as well. So it's likely still not going to happen as fast as a lot of people hope that it could, but I can assure you it's going to happen as fast as it possibly can. And then the longer time scale even than that is, what does it take for us to design all new altimeter equipment that's going to be much less susceptible to this problem? So that's something that kicked off really in late 2019 with the establishment of the new RTCA and EuroK joint committee to update the radar altimeter performance standards, specifically with this issue in mind, and not just for 5G, but for any type of external RF interference that could be near the operating band used by altimeters. And for reference, the last time the radar altimeter standards for civil aircraft were updated was 1980. And that update made very few changes from the original standard, which was from 1966. So there's has not been any kind of design requirement included that would really address this type of issue. A lot of altimeter equipment was designed to a standard that was put together well before any kind of cell networks existed, let alone 5G. So this is a case where we have to adapt to what is now a very rapidly changing spectrum environment, spectrum neighborhood around the altimeter band. And we're working that process as quickly as we can as well, but updating those standards and getting them in place, and then designing new equipment and proving that equipment out against those standards, that's a multi-year process. So that's kind of the longest time scale. But like I said, we're working all the things in parallel.
That makes sense. And, to shift gears a little bit, I know, that's been one huge part of, what these discussions have been like with FCC and with the wireless carriers is kind of explaining, how things are done in aviation, and they're not done overnight. And,
Right.
I think that's something that, yeah, sorry, go ahead, Nick.
Yeah, nothing. I was just going to mention some stuff for the folks that are listening.
Yeah.
The special committee that Seth is talking about is Special Committee 239. If anybody would like to look it up and see their charter and everything. So it would be RTCA Committee SC 239. And like Seth said, one of the challenges, and I want to touch upon this point because this is something I've been getting a lot of questions on from a lot of operators, is what happens in the case where, your rad altimeter happens to be one that cannot make the cut. And that's an area right now that we're still diligently discussing, both from a process approach with the FAA, as well as Seth said, at the box level, requirement level, to see what we can do. Because just like we talked about, it's not as simple as slapping on a bandpass filter and going out and recertifying the aircraft. It's a very difficult process and a very expensive process for a manufacturer to get this data with the bandpass filter and then have to go back and recertify an aircraft. That means all the existing fleet will have to be grounded for the duration of that, or would have to function under VMC conditions in these specific areas of exclusion until resolution or a supplemental type certification is completed.
A great point. With that, I'm seeing a lot of questions come in, and just being mindful of kind of the halfway point here. Thought we might jump into a few of those. And I'm just going to kind of read from the top here. So Simon Dean says, does the helicopter ASD or AD 2021-2313, the helicopter AD, restrict any RFM procedure with the word height in procedure? Does that requirement use the use of a radio altimeter data? Meaning, is the requirement height, or?
Well, the requirement is AGL. It's height above terrain, and the rad altimeter is the only instrument on a helicopter or an aircraft that can provide that. Everything else is relative to the ellipsoid in terms of height measuring equipments and such. But there's no restrictions. The restrictions are primarily any instrument that interfaces or uses the rad alt data in order for it to provide information or situational awareness to the crew. Things like HTOS, EgyptWhiz, things like automatic flight control functions, hover hold, decision height, etc. So those functions would be the ones that would be impacted by not being able to depend on the rad altimeter to provide accurate and reliable information through these RF zones that we're talking here. Seth, I don't know if you want to add anything to that.
Nope. Yeah, I agree with that.
So I'm going to take an easy one here. Michael Latour, apologies if I'm mispronouncing that. So beyond what helicopter OEMs are doing, is HAI also soliciting AMOCs to the FAA-AD? So also new initiative that we're partnering with the FAA on, as was mentioned a bit earlier, there's a number of working groups, and we're working closely with the FAA and starting to kind of hone in on the rotorcraft side. One thing we're really trying to do is make sure, the operators, voice in this process is heard. With an influx of AMOCs coming in for approval, there's a certain level of, just administrative work that can be expected, and there's a lot of pressure to conduct, those in a timely manner. So what we have done is set up a website that we'll be sure to send out after this, but rotor.org/5G-AMOC. And what we do there is kind of outline who would necessarily need an AD, or who would need an AMOC based on the AD and the NOTAMs, and kind of a checklist to go through there. And then also a form where you could provide some information about the restrictions that you may be facing or that you expect to face once 5G is deployed on the 19th. And what we're going to do is hold regular meetings with FAA to kind of relay a lot of that information. So if we see some trends and something that could potentially relieve, a larger number of operators experiencing the same thing, or if we can address an issue in a region in the country where, say, service would be, inaccessible, we'd be able to identify that in a timely manner and have a coordinated system to go through it. But, Nick may have more to add to that, but just wanted to do a quick plug for that, and we'll send more information out later.
No, I think that's excellent, and people should go and check that out, definitely.
All right. So I'm going to move down to the next one. Controlled airports are not going to be the primary concern for helicopter operators. Most are not taking off and landing in those areas. Is it going to be other areas that are not in controlled airspace, but within potential 5G C-band interference zones? And how is the FAA addressing those concerns?
That's an excellent question. Currently, the FAA has two separate committees for the AMOC. There's a fixed wing committee for the AMOC, and there's a Rotorcraft committee for the AMOC. John and I have been, as well as Seth, have been participating in the Rotorcraft meetings. Each committee is looking at the issues and challenges of the various heliports and helipads, as well as the fixed wing community from their own perspective here. The important thing is that the FAA is currently composing a detailed database of all helipads and heliports. And they're referencing back to these prime economic sectors in which the cellular industry is actually activating their 5G operations. And in doing so, they're examining the potential implications or restrictions that may have to be imposed on those heliports and helipads. That's going to be an ongoing and dynamic process. As I said earlier, they're doing this rollout in phases. So every 3 months, we'll be getting additional towers. So these assessments from the FAA against these databases will be ongoing, at least for the foreseeable future, until we stabilize the number of towers popping up, which at some point I would expect that the AMOCs would be more under control and would not have to be coming out in that frequency.
So we got a question come in. There were some great slides shared earlier. Would that be something that could be shared after the presentation? If you guys had any of those, we'll be sure to collect them. So appreciate that. And then, great. So we've got another question. If the RADALT manufacturers are already working directly with FAA, why is there a need for an extra level of OEM implication to request AMOCs for systems that we know will not have any interference?
Yeah, so I'd say I don't know if there's any cases where we can say we know there is absolutely no interference. It's a broad spectrum of performance. There certainly are altimeter models that we think we have data that shows they perform very well and are very robust. And any errors, either undetected erroneous altitude output or loss of function for those particular models is going to be extremely unlikely. but there's a whole lot of other cases where there's a likelihood of interference, but it kind of depends on how the aircraft is being operated, where you are relative to the 5G towers, and so on. So it's not really a binary thing of this altimeter model is susceptible, this other model is not, and that's kind of what that initial process with the AMOCs accounts for. So you have a variable protection radius based on the actual measured capability of a given altimeter model. Longer term, when we look at retrofitting aircraft with filters as needed, and eventually developing new standards and designing new equipment to meet those standards, at that point, things will be a little more controlled, and we'll be able to say, regardless of how the aircraft is operated, we don't think interference is likely. So that's kind of the end state that we want to get to. But in the meantime, we're going to be living with 5G deploying before the aviation industry can fully react to it in terms of updating altimeter equipage. So we want to account for whatever level of performance we can adequately demonstrate for any models that do perform better. But it's not as simple as just saying, the radalt on my aircraft is good, so I shouldn't have to worry about this anymore.
Yeah, the other thing I will just add to Seth too is remember that a manufacturer from a regulatory process cannot really apply for
Right.
an installation approval, right? So we also have that part in there, which is critical because Seth's company may produce a radalt that can perform reliably up to a certain altitude with certain accuracy. However, there's compromises that are introduced in terms of installation performance and cable loss, et cetera, angles with respect to the ground, et cetera, how the beam strikes and reflects back. So all those elements have to be factored in. And because the process is heavily based on installation, the OEMs are forced to follow the AMOC process as being the only way to clear us for usage and exception within these spaces.
Kind of a follow on to that. So unless there are modifications required on aircraft to mitigate the interference, where the OEMs may need to release bulletins to incorporate these systems, I may be missing part of that. Pardon me on that one. Maybe we'll jump to the next one. Or
well, we can. I think I got that one.
Yeah.
I mean, to reiterate where we are today, because like Seth said, everything's changing hour by the hour, day by the day here with every meeting we have. So it's a very fluid situation. Right now, if the rad altimeters meet the criteria that we as the aviation industry and manufacturers have put together, that show that an aircraft model with this particular rad altimeter model can operate successfully, the OEM should proceed with an AMOC application. And companies like Boeing and Airbus and Sikorsky and others are doing that right now, right? We're either working these AMOC applications or we're submitting them in. No AMOC application as of today has yet been approved, but as Seth said, the FAA's goal is to have these approved within 2 days eventually when they get it right. But the whole process here of dealing with a particular RA that is not going to be able to comply to the requirements of the RF is territory unknown right now. The FAA is trying to grasp the 80 percentile, 70 percentile of aircraft in order to mitigate and not bring the airline industry to a halt. So we're slowly peeling back the onion, so to speak, to get to those corner cases of what do we do and how do we handle cases where rad altimeters are not going to be able to perform within those sectors.
makes sense. So has rad alt manufacturer testing yielded any information on the expected behavior of an RA, and should it experience any interference? Kind of fluctuations there?
Sure. Yeah, I can speak to that. So we at Honeywell have done pretty substantial testing on all of the altimeter models that we produce, and the behaviors we observe in laboratory testing do vary from model to model. But generally, we've observed everything you can imagine. So everything from uh, you know the altitude output getting a little noisier. Maybe you've got things bumping around plus or minus 50, plus or minus 100 feet, something like that, to complete loss of function, where it just breaks lock and it's not giving you any altitude information, to sustained erroneous output that is not indicated as erroneous, which could be hundreds of feet or thousands of feet away from the true altitude. So that's, like I said, that's based on laboratory testing. In a real world scenario, we obviously expect things to be much more dynamic than what we can faithfully represent in the lab. So there's going to be a range of different impacts there. But our conclusion has been, based on our testing, that there's not really any kind of failure mode that we could safely rule out. So you could have detected faults, you could have loss of function, like I said earlier, you could have undetected erroneous output, which could constitute hazardously misleading information, depending on how that information is, how that altitude output data is used on board the aircraft.
So to this point, has anybody done actual, live flight testing? Has that occurred, and is that something we see kind of on the horizon?
Yeah, we are currently involved with manufacturers like Seth's company and Collins and others, that we are engaging with them to perform actual flight testing. One of the things that's kind of unique that is pushing us away from doing extensive flight testing, particular on aircraft that are using rad altimeters that are not that are showing good performance within the requirements that we have, is that the FAA, through the AMOC process, as I said earlier, are treating the rad altimeter susceptibility data as conformed data. And they've intentionally allowed OEM manufacturers to apply, or STC holders, to apply for the AMOC without the need to go back and do additional flight testing. Now, again, we have that corner case that we talked about, where we have rad altimeters that may require some modification. Modifications may be in terms of a bandpass filter going in front, or maybe some other changes that may have to occur. Those cases have still not been elaborated or debated. But the FAA has realized that if they would have forced both the rad altimeter manufacturers to do the additional testing for susceptibility, and then have to impose additional reflight certification to the aviation industry, that would be a mountain that they would never be able to get under. I mean, it would be a tremendous amount of workload. And the FAA was very adamant from the beginning that they did not have the infrastructure, nor the expertise to support such level of broad flight testing in such a short time.
So is there any concern that repeated exposure to 5G signal could cause permanent damage to existing or installed rad alts, which may or may not be evident to the maintainer or the pilot?
Yeah, so I'd say, based on what we know right now, I think that's relatively unlikely, given the levels that we've observed failure conditions in our laboratory testing for most of the altimeter models. So generally, there will be some kind of erroneous output or loss of function at a much lower level than you would actually have a concern with any kind of irreversible damage to the equipment. And I think that even goes with repeated or prolonged exposure. So that's not an area of significant concern that we're tracking right now. But we are still trying to get more information nailed down on what to actually expect for a worst case environment, worst case exposure to interference. Right now, it's something that maybe could be comparable to some of the most severe rotorcraft turf environments that we've had to deal with in the past. and in a much more complex way, given the nature of the waveforms and things like that. So I wouldn't be too concerned about that at the moment, but again, it's one of the things we don't want to rule anything out until we have all the information to really drive that to closure.
So are there protection boundaries? Are they very accurate, or is there some boundary overlap for interference? If that makes sense. I think getting at kind of maybe perhaps the graph that you were talking about or opened with.
Right. Yeah. So there's a lot of steps in the middle to go from measured altimeter performance data in some kind of laboratory test to a protection radius value. You have to so that protection radius value is really contingent upon a lot of parameters that go into that calculation. And the task force discussions we've had between industry and FAA to nail down all those parameters for our first pass has really been focused a lot on the transport category airplanes case. So I think there are parameters in there that we have an opportunity to refine and use better values that are more appropriate to rotorcraft operations when we apply this same process for rotorcraft AMOCs. So, for example, limiting the maximum altitude at which we're truly concerned about safety hazards associated with malfunctioning of the radar altimeter. For a rotorcraft, you may not care about your altimeter operation above, say, 500 feet AGL. On a fixed wing aircraft, you may care about it at 1,000 feet or 1,500 feet AGL, because it's going to start changing your auto land modes and doing all sorts of things that the pilots may not even be aware have anything to do with the radar altimeter. So there's things like that need to be refined, and even beyond just tailoring that more appropriately for rotorcraft scenarios. Moving forward, we see opportunities to refine those calculations to take more complete advantage of what we know about the 5G network operations in terms of their radiated power levels and antenna patterns from base stations, as well as the performance and capability of the altimeters. So one additional complexity that has not yet been introduced is generally the altimeters can tolerate higher levels of interference when they're closer to the ground. So that's a somewhat of a good thing if you can adequately take advantage of it. It means you would effectively have a smaller protection radius when you're operating lower to the ground, which you would want to be able to take credit for, because that's when you're going to be closer to potentially a 5G base station. That's not built into the initial AMOC process yet, but that's going to be one of the things that we try to work in as we add complexity and try to go from that initial 70-80% of the problem to starting to pick out more of the remaining areas.
I like this question here. Can someone please explain in plain English how this will affect operations for law enforcement organizations who patrols huge areas at night on NVGs and performs multiple off-field landings?
Well, I think it's pretty evident, right? I mean, the NOTAMs that were released today cover both airspace, procedure, and aerodromes, right? So if you are, let's say, in the New York City metropolitan area, where you have JFK on the south of the island there and LaGuardia on the north, there may be zones within that area that you may have to drop below a certain altitude, or there'll be an altitude of a no-go zone. Like Seth said, we have seen information that shows that the lower you get, the better your performance is. So all that will have to be weighted in the way operations are conducted going forward. the biggest issue, and just to build up on what Seth was saying before too, with a helicopter versus a fixed wing is, a fixed wing is always cruising along, and the lowest speed is going to get is probably around 150, 170 during landing. The dwell time of an aircraft when it hits the lobe of either a fundamental spurious noise emission is going to be very limited exposure in terms of the dwell time, where a helicopter has the ability to hover in place and can get has higher susceptibility rate because of the higher load dwell time exposure. So I think all our federal police, fire rescue, ambulatory will have to become aware, and the pilots, particularly the operators, may have to be conscious at all times about their rate altimeter, and have a heightened awareness that there's always a case that they may have erroneous or misleading information, like Seth said.
Makes sense. So I want to check in with you guys because I know we got a late start, later than our usual 4 o'clock. We are kind of at the hour, but I know we still have questions that are coming in. Would you guys care to be available to stay on for maybe a few more, or we pretty much the time?
No, absolutely.
I know you've got stuff. You good? Okay.
Yeah.
These guys, you wouldn't believe it. They're up every night till 9, 10 o'clock doing these, and then taking them first thing in the morning. Very impressive. So I appreciate that. And I appreciate the discussion too. I think this is all really informative, and appreciate all these responses. So I think this is very beneficial. So based on the briefing info, it appears that operators are dependent upon the RA manufacturers and the aircraft manufacturers to move quickly to achieve the AMOCs. And until this happens, the restrictions in the AD will apply, unless today's exemption applies. Is that correct? That's
correct. It's a symbiotic relationship. All OEM manufacturers have very close relationships with our suppliers like Honeywell, Collins, and others. That's how the industry operates. We have a very close working relationship. I can assure you, Seth and I talk almost daily, if not hourly, either directly or through email. So it is the way the industry functions. It's a good relationship. Unfortunately, we're faced with unprecedented threat here. Unprecedented threats really require unique solutions. So we're doing the best we can. As Seth said, we're working at the best speed we can to address this issue in the safest manner possible.
Yep, fully agreed. And I think the Rotorcraft side of things is not the only case where I think the operators have frankly been getting the short end of the stick on getting kept in the loop and knowing what to expect. That's happening on the transport airplane side of things too. Unfortunately, in a lot of cases, the answers that the operators are looking for are things that no one can really provide at this time, whether that's the altimeter manufacturer or the aircraft manufacturer. But I think as we're gaining more information and getting through these AMOC processes, I certainly hope that gets communicated out much more broadly, and we can establish a more standing line of communication, because things are going to continue to change. This is not going to be a one and done process.
Absolutely, and that's something HAI hopes to achieve as well. Leading into this, there was a lot of sensitivity around the discussions, and hope that we could move the needle on some things, and there still is, but I think we're at a point now where just transparency and the information sharing is critical, and making sure that it's coming from both ways too, so that you guys are hearing from us and vice versa. So appreciate that. So a comment kind of following up from this previous question. From an OEM perspective, we're working with our RA suppliers to gather data to support that their equipment is either not susceptible to these potential interferences for 5G, or we will need to implement solutions to mitigate them. So that makes sense. So the next one we got up is what would the interference look like to a pilot, and how sudden are the impacts once in the zone?
Well, there's two tiers of potential failure condition manifestations you would see. It would either be erroneous detected, in which case your rad altimeter is not going to receive valid reflections, and it's going to be capable of identifying it. And that would typically manifest itself on an EFIS display as either as a red X by declaring your rad altimeter indication invalid, or the other failure condition would be erroneous erroneous undetected, in which case you would be continuing to get values that the system would declare as valid, but they would not correspond to the correct altitude. And that's the more dangerous of the two, obviously, right? Because if you do have a detected one, it's detected, the system is designed to identify that. It's the erroneous undetected, particularly when you're within a few feet or a few tens of feet. That's probably the most dangerous one of all, because operators have learned to depend on the rad alt, or more importantly, they're depending on other systems interpreting rad alt information correctly. And when that doesn't happen, you can have a cascade effect of failures. So while losing rad alt itself or having an erroneous undetected value be present may not seem as a critical failure, when you start adding additional systems that depend on the validity and accuracy of that number, then you have a cascade effect of failure buildup that can lead to a catastrophic event potentially.
I know in a lot of these discussions, that's kind of been brought up, is the trust that we're trained to rely on our instruments, and then you kind of throw something like this in there and can really drastically reduce safety. And also, I mean, I know too, I've heard from many of our different operator segments that have said there's varying levels of dependence on the rad alt for certain operations, and that's something that we've been trying to factor in as well. And I think we'll continue to be able to do that. And really, what we saw through the petition, is there's potential avenues for some of those kind of operations, where we could look to an exemption to the rule, in addition to AMOCs as well. So what are the technical challenges to modifying existing radio altimeters to provide protection from the 5G C-band interference?
Yeah, I can take that one. So really fundamentally, there's two primary modes of interference that we're concerned with, two different things that can happen. And this is sometimes referred to as front door coupling and back door coupling. So one is the 5G networks are putting out very high power signals in their own frequency band, which is separated from the altimeter band. And the altimeter receivers don't have perfect brick wall filtering built in, so they pick up some of that high power energy. It leaks into the receiver and can cause various issues. The other is that those 5G networks are also going to be leaking out much lower levels of interference, but directly into the altimeter frequency band. So we call that the 5G spurious emissions case. And both of those are potential areas of concern. For the most part, the former case, the 5G fundamental emissions inside their frequency band, seems to be the driving factor, at least currently, when it comes to this issue. For most altimeter designs that are impacted, that's the primary mechanism of concern. So in that case, the solution is, at least on paper, very straightforward. You need to implement more filtering, more rejection of those out of band signals from the other frequency band before they get into your receiver. So that's something that can potentially be implemented in new radar altimeter designs in the receiver in the box itself. or it's something that we're going to be looking at potentially doing retrofits, installing external bandpass filters in the RF cabling between the receive antenna and the altimeter box. So that can introduce some degradation to performance, adding that filter. It adds additional insertion loss. There's some other considerations as well. So if we're going to be doing that, we need to make sure that the filter that we use is going to provide the necessary rejection without degrading the system performance too much. The other case for potential 5G spurious emissions is one that's actually could be a much bigger issue when looking at the long-term compatibility picture. Because even if we implement perfect filtering in our altimeter designs and completely block out those signals from the 5G band, if they have signals that are leaking directly into our frequency band, we have no opportunity to filter those out, because that would then filter out the signals that we're trying to actually receive and process from the reflected signals from the terrain. So that's a case where if that's driving our compatibility long term, the only opportunity is to actually degrade the performance of the altimeter to reduce that interference threat. So that's the case that we're working more really on the regulatory side of things than on the technical, because we've seen information from the telecom industry that they think their spurious emissions performance is much better than what the FCC regulatory limits are. So we're trying to obtain that data and verify that. And then if that is true, then we want to get it actually codified with the FCC and say, yes, even new equipment that's developed for 5G networks is still going to provide that lower level of interference, and we can actually depend on that long into the future.
You mentioned retrofits. I'm curious, what is the time that that would take to do? Is that going to vary across different aircraft? What does that look like for helicopters?
Well, as Seth mentioned, and this would apply primarily to the set of rate altimeters that would not be able to meet the current requirements that we've established. In those cases, I think it would be a very surgical decision. You know, we would look definitely in maintaining the original unit if a bandpass filter on the front end of the receiver box would mitigate the issue. Should the performance hit be unsustainable or intolerable by the operational requirements of a specific aircraft or helicopter, we would then certainly have to look at a different model rate altimeter to be installed. And that in and of itself would not be a very palatable solution, I'm sure, to a lot of folks out there, because typically a project like that may take anywhere from 6 months to a year to complete as part of a STC. It would definitely be a supplemental type certification and a modification to the original type design.
Yeah, I agree with that. I think the retrofitting with filters is a much more palatable and likely faster option if it can be done. And like I said, we're already working with FAA to see if there's a fast track path to STCs and get them the data they need for our altimeter performance associated with those filters to accommodate that as quickly as possible. I can say we're getting, we've evaluated some filters already, some filter parts, which we've used in the past with altimeters for other applications. And we're in the process of getting additional filters to evaluate some slightly different parts that offer different performance. We'll be doing that over the next few weeks. And hopefully, you know, once we can make that evaluation on our models that are impacted, we can identify that as the appropriate fix, and then go from there to actually get things implemented, get STCs in place, and try to work on, you know, getting service bulletins out to actually retrofit fleets as needed.
So I think we'll do one more and kind of do some final thoughts here. I know we've gone over a little bit, but so is there an estimate what it will cost to replace, retrofit the commercial fleet? And is there any indication that either the wireless companies or the federal government will be willing to subsidize this?
So I don't know what estimates are available today, but I can assure you the aviation industry is keeping a ledger open and tracking all the costs that are being incurred throughout this process. John, you may have some more thoughts on this as more of a government relations minded person, but from my perspective, I don't think the aviation industry should be going after the telecoms for this. They were complying with what the FCC was going to be was saying was going to be okay. They invested heavily in the new spectrum. I don't really blame them for the position they find themselves in. Whether or not the government and the FCC and the previous administration did their due diligence to try to prevent this issue, that's maybe another story. So I'm sure there will be a flurry of activity in that regard once we resolve the immediate near-term issue, trying to minimize impacts to operations. I'm sure a lot of people will be shifting their mindset into recouping some of those costs.
Well, I certainly do have thoughts. Yeah, I would agree with you as well, that this was an issue that was largely created by a lack of due diligence by the FCC. Things moved too quickly, and a process that's established was not resolved. And I think there's a bigger picture issue that the aviation industry at large is going to have to address as far as oversight and how this works. But as far as costs, it's definitely something that is being discussed. So I appreciate the question. And Nick, I don't know if you had any more to add here.
No, I like Seth said, I think everybody's being very cost sensitive. And obviously there's also a legal perspective too. There's a potential liability perspective that comes along with this too. So it's not just the financial, there's also a legal perspective that is still being debated and discussed by the OEMs and the manufacturers here too. And I agree with you 100%. I know a lot of people want to put the blame on the cellular providers. Unfortunately, they're not the ones that actually created this situation here. So that's all I have to say.
It was a $82 billion purchase. Understand the position they're in, and hopefully that we can continue to make progress on a way forward where we can coexist. I know that's being said a lot, but I feel the sincerity of it is increasing despite what you read and see out there. There's a lot of people like ourselves here that are trying very hard to get to that point, and we'll continue to do so. And as we've done, for HAI and for your companies as well, we've explored every avenue here to make that a possibility, regulatory, through the administration and otherwise, and now directly between each other. That's I think hopefully progress should continue on that front, but we'll certainly be keeping all options in mind. But with that said, I'll kind of give it to you guys if you have any final thoughts here for the evening.
I would just like to thank you and Dan and HAI for providing Seth and myself this forum to be able to educate everybody. I think there's been a lot of misinformation out there. A lot of it basically could be blamed on some of the lobbying the activities that go on between the stakeholders in such cases. But again, I think it's a good forum to educate our users and our members here as to what really is going on and all the efforts that the helicopter and aviation industry is putting into this issue.
Yeah, agreed. Thanks, HI very much for setting this up and inviting us to help bring some of these concerns to light and explain things and hopefully address a lot of people's questions.
Yeah, well, I think you certainly did that. You certainly made my job easy. You know, you guys are a wealth of knowledge and again, so deeply involved in all the discussions. And, you know, we'll continue working around the clock on this. And, you know, again, really appreciate you coming on, and we hope to have you back and do a follow-up session as you know, a lot's happening here. But thank you both for coming on tonight and for sharing these thoughts and getting through some of these questions. We had a few we didn't get to tonight, but again, want to be conscious of time, and what we didn't get to, we'll be sure to circle back on. And want to again thank everybody for coming on tonight, and appreciate your time. And if you have any other thoughts after this, please do let Dan or myself know. And again, you know, we've got this this website set up with the 5G AMOC. Consider those, you know, to be a resource and to provide input. And would also mention, you know, there's rotor.org/radalt. So if you're looking for material on information that was discussed today, a lot of it you'll find there. And if there's other information or material that we can provide, don't hesitate to reach out. And again, thanks a bunch, and I'll pass it back to you, Dan.
Okay, well, thank you, John. Thank you, Seth. Thank you, Nick. I just sat here with rapt attention throughout the entire webinar. And one of the things that kept occurring to me is I'm grateful for the work that all three of you have been doing on behalf of the industry leading up to this. I know you guys have spent months trying to mitigate or find a solution and mitigate the issue before it ever got down to this point. And honestly, I'm grateful for the work you guys have done. I think it could have been so easy to just roll over, and we would have had to deal with even worse scenarios than this. And so thank you for not only tonight, but for all the work you guys have been doing over the last many months. On behalf of the industry, thank you. Gentlemen, I'm just going to wrap things up now. You're welcome to close off your cameras and leave. I did leave the web address up for a little while. People can write that down. Maybe do a screen capture with your phone, do a print screen, something like that. That's entirely up to you. But I wanted to make sure that you saw the information. HAI will continue to update that. We debated making that information numbers only, and then we realized that this is very important for the entire industry. So we'll make sure that that page continues to go on. We do have some upcoming webinars. We may try to bring another webinar in next week depending on how things go. I'm trying to reach out to our subject matter expert next week, Kim Hutchings, to see if she may be able to adjust her schedule. We might try to change that to January 27th. We may try to switch. If not, we will try to do if necessary, try to do a 5G update on the 27th, especially regarding the HAI petition for exemption that was granted today that John mentioned. We do have a feedback questionnaire coming to you shortly. We would appreciate your assistance. I know some of you, this is the first webinar you've been with us on. Please take the time to let us know what you thought. What did we do right? What did we do wrong? What can we do better? If you have ideas for upcoming webinars, we'd appreciate that as well. If you do have any other thoughts for HAI in general, we're grateful for that information. The easiest way to do that is a direct email to Jim Viola, the president and CEO. He couldn't be with us today, but he does read all those emails, and he does share the emails with the staff for tasking. So if there's some thoughts you have on what HAI could do on behalf of your company or on behalf of the industry, please let us know. That does conclude our webinar for tonight. We appreciate that you stayed with us for so long. Until next week, we do ask that you fly safe and be safe, and we'll be in touch again very, very soon.